Hi students, in today's class we are discussing about the basic concepts of stereochemistry, which is the first concept in stereochemistry. We all are familiar with the isomerism. Isomerism are of two types. One is constitutional isomers or structural isomers, and the second one is stereoisomerism. Stereoisomerism is coming under the topic stereochemistry. Okay, first we have to discuss about the constitutional or structural isomerism before jumping into the topic of stereochemistry. So first concept is constitutional or structural isomerism, which arises due to the difference in bond connectivity. Okay, bond connectivity means the arrangement or the way in which the atoms connect groups or atoms are the sequence in which the different atoms or groups are bonded to each other in a molecule. It is called bond connectivity. So the constitutional or structural isomers arises due to the difference in bond connectivity. They are of 5 types. That is, first we all are familiar with these 5 isomers which we are already studied in small classes, in school classes. First is chain or skeletal isomerism. Second is positional isomerism. Third is functional isomerism. Fourth one is metamers, and fifth one is tautomers. Okay. Next, the stereoisomerism arises due to the spatial arrangement. Okay, all atoms are arranged in 3D manner, which is called spatial arrangement of that atom, and this stereoisomerism arises due to the difference in spatial arrangement of atoms. Okay, and they are of two types. One is configurational isomerism and second one is conformational isomerism. The confusion arises from here, configurational and conformational. The words are sometimes confusing, so understanding first from the basic is necessary for jumping into the higher topics in stereochemistry. First is configurational isomerism, which is classified into optical isomerism and geometrical isomerism. Optical and geometrical isomers are coming under the heading configurational isomers, which is stereoisomerism. Okay, optical and coming to this configurational isomerism, first one is optical isomerism, which arises or which causes which arises due to the asymmetry of the atoms or chirality of atoms. Optical isomers arises. Okay, next one is geometrical isomers. Geometrical isomers arises due to the carbon-carbon double bond. Okay, carbon-carbon, the one where there is a carbon-carbon double bond, there is a restricted rotation about this carbon-carbon double bond. So configurational isomers arises due to the restricted rotation about the carbon-carbon double bond is called geometrical isomers. Okay, next one is conformational isomers, which arises due to the free rotation of carbon-carbon single bond. Here configurational isomers, and in that geometrical isomers there is carbon-carbon double bond, there is restricted rotation. which causes geometrical isomers. Okay, next one is confirm. Here we uses E and Z rotation, so E and Z nomenclature, etc. Okay, here we uses dextro-rotatory, levo-rotatory, etc. Here conformational isomers, which arises due to the free rotation of what, carbon-carbon single bond, which the Sohor's projection, Newman projection, all are coming under this conformational isomers. Okay, we are going to discuss secondly the conformational isomers. In today's class we are discussing about only constitutional or structural isomers. In next class we will discuss about the conformational isomers, and in third class we will discuss about the configurational isomers. Okay, these are more confusing of these two. This is configurational isomers is more confusing, so especially the geometrical isomers. Okay, so we are going to discuss about in the third video. In today's video we are already discussing about the constitutional or structural isomers. Okay, so in structural isomers, the first one is chain isomerism. The chain isomerism or skeletal isomerism, okay, arises due to the see, this is the example of chain isomerism. Here this is butane. In this constitutional or structural isomers, all isomers are having same molecular formula, but they are differ due to the bond connectivity. The first one is chain isomerism. This is butane, and this is 2-methyl propane. Okay, 1, 2, 3. So 2-methyl propane and butane are chain isomers, which differs due to the chain structure or skeletal structure of carbon bonds. Okay, okay. Next example is pentane and 2-butane are also examples of chain isomers. We are not going to discuss detail about this constitutional structural isomers because you all are familiar with this from your school classes itself. So next one is positional isomerism, which arises due to the position of difference in position of what, functional group. Here this is 1 bromopropane and this is 2 bromopropane. Okay, here the bromine is the functional group, which in this it is in position 1 bromopropane. This one first carbon alkyne, first carbon atom. In here it is in the second carbon atom, so 2 bromopropane. Positional isomerism arises due to the difference in position of functional group. Third one is this, okay, positional isomerism arises due to the position of functional group and also by the position of double bond. Here not a functional group present, but a double bond is present. In this it is alkene. First one is both are butane. First one is 2-butane and second one is 1-butane. So they are also positional isomers. Okay, next one's functional isomers. Functional isomers is due to the difference in functional group. Okay, here look, 2 carbons, 5 hydrogens, 5 plus 1 6 oxygens and 1 oxygen atom. 5 plus 1 hydrogen, 5 plus 1 6 hydrogen atoms and 1 oxygen atom. Here also 2 carbons, 6 hydrogens and 1 oxygen atom, but the functional group, so the molecular formula is same, that is C2H6O. Okay, in both case, but in this case the functional group is OH, hydroxyl group, and this in is O. Okay, so the both are different due to the not the position but the functional group present. Here OH, here O, so that type of isomerism is called a functional isomerism. Okay, next one is metamers. Okay, metamers are look at these two examples. First one is CH3 CH2O CH2 CH3. Next one is CH3O CH2 CH2 CH3. What are the difference here? The functional group is same O, but look at the left and right side of the functional group. Here CH3 CH2 CH2 CH3. Here in the left side CH3 only, and in the right side CH2 CH2 CH3. That is the way in which the atoms arrange between the about the functional group. That type of isomerism is called a metamerism, and these two are called metamers. Next one is tautomers. Tautomers, we are familiar with the keto and enol form of carbonyl compounds having alpha hydrogen. Here it is a carbonyl compound. Okay, CH3CO CH3. CO is the functional group, which is carbonyl group, and this is the alpha carbon. Alpha carbon means the carbon atom which is directly bonded to the functional group. That is, here it is also alpha carbon, it is also alpha carbon. The hydrogen atoms attached to that alpha carbon is called alpha hydrogens. So carbonyl compounds having alpha hydrogens exhibit tautomerism. Keto enol tautomerism. It is the keto form, CO group. It is a enol form. Here 1 2 3 4. Okay, enol form. Okay, that is what first one which we all are familiar. It is next example is nitroazide form. Okay, tautomers, first of all, tautomers exist because of the shift of hydrogen atom from one atom to another. Okay, in the same molecule. Here the hydrogen atom from this carbon, or from this carbon, is shifted to the this oxygen. Okay, here the double bond. So from this carbon, hydrogen is shifted to this. Okay, this double bond shifted to this, so it will become negative. The hydrogen will shift from here to here, and here will become a double bond. Okay, that's how it is formed. That is, it is keto enol